Okay, now screen sharing is there. Okay. Okay, so new topic will start some because I feel today I'll just give you next topic. See, numerical we have to keep discussing. As I told you, mechanics is all together topic. Even rotational dynamics, when we discuss, we have to discuss again everything. See, today we'll discuss work, power, energy, that new topic. Okay. In that, today we'll discuss about work. Okay, topic is work, power, energy. First is of course work. Okay. So the questions will be asked, calculate work done by a force. Now the moment question is asked, calculate work done by the force, you have to classify into two parts. What are the two parts? One part will be work done by a constant force. Work done by constant force. Okay. Other part will be work done by variable force. Okay. One is work done by constant force, other is work done by variable force. Now, when we'll say the force is constant, remember force is a vector quantity. Force is a vector quantity. So force magnitude, as well as direction, right? These two quantities should be constant. Magnitude should be constant as well as direction should be constant. Then only we'll say it is a constant force. Remember that. Whenever we say any vector is a constant vector, then its magnitude, the value of it, as well as the direction should be same. So let's first concentrate on work done by constant force, because work done by variable force is based on work done by constant force. How it is, that we'll discuss. That how by doing constant force, if you understood it, variable force also you can do it easily, but there are some initial changes. Once you'll make the change, then we can apply similar formula. Okay. So work done by constant force. One formula is there. That formula you have to remember. Work done by constant force. So it is nothing but the dot product of force and displacement. F dot S. Right? Dot product. Remember, for a vector, dot and cross has a different meaning. Like in multiplication, generally in arithmetic, what do? You 5 into 3, you write 15. 5 cross 3, you write 15, right? For the arithmetic operation, it is okay for maths part. But here, in case of vector quantities, dot and cross has entirely different meaning. When we say that we are taking a dot product of two vector quantity, meaning of that is this will be equal to magnitude of force, magnitude of displacement, and cos of angle between them, cos theta between them. Okay. So if we have this one, cos theta between them, then we'll say it is a scalar quantity. So work done is equal to F dot S, magnitude of force, magnitude of displacement, cos theta, right? Where theta is angle between force and displacement. Okay. Theta is angle between force and displacement. So this is how dot product is defined. Angle between force and displacement. Okay. Angle between force and displacement. So this will be dot product. Remember the quantity what we are getting in a dot product. Dot product will be a scalar quantity. So dot product is also called as scalar quantity or scalar product. Okay. Dot product is also called scalar product because the quantity what we are getting will be a scalar quantity. So work done is nothing but a dot product of force and displacement. Force and displacement, which is nothing but magnitude of force, magnitude of displacement, and cos of angle between. Okay. Now let's concentrate again on the work done. F dot S. Magnitude of force, magnitude of displacement, and cos theta. Now remember, this quantity, magnitude of force, magnitude of any vector quantity will never be negative. So it's always positive. Always positive. It's a magnitude value. Similarly, magnitude of displacement, this will always be positive. What about cos theta? Now, cos theta can be positive, can be negative, can be zero. Okay, can be positive, can be negative, can be zero, depending upon theta. Depending upon theta. And what is theta? Theta is angle between force and displacement. So if you'll see here, if there is a force and if there is a displacement, but still work done can be zero. Still work done can be zero. Right? Like suppose there is a wall. In your room, there is a wall, right? And you are applying force on the wall continuously. Wall is not moving. Right? Wall is not moving. In that case, displacement is zero, work done is zero. But suppose there is a suitcase on the surface, right? And suitcase is moving by 10 meters. And there is a gravitational force of this on 100 Newton, suppose. So there is a force, there is a displacement. But in this case also work done will be zero, because magnitude of force, magnitude of displacement, and cos angle 90 degree between them. Force and displacement 90 degree. So the moment work done, the moment theta is 90, work done will be zero. So we can say that work done will be zero if the angle between force and displacement is 90 degree. So basically now we have to discuss about cos theta, that how the cos theta will behave, and based on that how the work done will be. That we'll discuss in the next page. So till this it is okay. Anyone has any doubt in this?
Sir,
Yeah.
the last one that you just wrote, the W F vector point dot S vector, sir, that can you explain with a visual example?
Yeah, suppose weight of this is 100 Newton, gravitational force is 100, displacement is 10. So these two quantities are non-zero. But cos 90. Now what is cos 90? Cos 90 value is 0. So if you multiply 100 into 10 into 0, how much the quantity will be? It will be 0.
Yes, sir.
So that's what I'm trying to tell. That see, there can be force, there can be displacement, but work done can be 0. So it's not necessary when displacement is 0, only work done is 0. Or force is 0, then only work done is 0. Work done can be 0 if force is there, displacement is there, but the angle between them is 90. Right?
Oh.
So that case we have to remember. Now again we'll discuss this in detail in the second page. So let me go to the next page and then let's discuss it. Okay, so coming back to the work done again. Remember, this is work done by constant force, right? Work done by constant force. I'll tell you what is the difference, why we cannot apply for a variable force. Work done by constant force, F dot S, dot product, magnitude of force, magnitude of displacement, cos of angle between them. Okay. Now cos theta, how we define cos theta here? So this is the displacement, this is the force, this angle is theta, right? Suppose on a box or any object, for that sake, to make you understand, I'm just drawing it. Forces applied angle theta, right? And we calculate work done like this. Now if you'll see here, theta is between tail of one vector. See, this is the tail of displacement, and the tail of other vector. This is the tail of force. So theta is tail of one to the tail of other. If you remember vector, we discussed head and tail. So we are talking about tail of force and tail of displacement. And theta value should be between 0 to 180 degree. It cannot exceed 180 degree. Why it cannot exceed 180 degree? Suppose it will exceed. Suppose displacement is this side and we are drawing force here. Then this side angle is more than 180. But this side angle will be less than 180. So we'll take this as theta. We'll not take that as theta. Okay. So theta is the angle between force and displacement. So we can always take this side angle, theta, and then we can calculate it. So theta will limit itself between 0 to 180 degree. Now the problem is cos theta. It's not just theta, it is cos theta. Now cos theta depends on the value. So there are three cases we have to understand here. Case 1. Case 1. Theta is between 0 to 90. Theta is between 0 to 90. If theta is between 0 to 90, cos theta will be positive. If theta is between 0 to 90, cos theta will be positive. Cos 0 is 1, if you remember. All the value between 0 to 90, cos theta is positive. So work done in that scenario will be positive. Of course, provided force and displacement should be there. That is, of course, hidden condition. We cannot just talk about any work done if force is not there or displacement is not there, right? So if both is there and it is in the hand of cos theta, so angle between them is 90, then we will say that work done will be positive. Then case 2, theta is equal to 90, exactly 90. Okay, theta is 90, exactly 90. Cos 90, what is cos 90 value? Cos 90 value 0. So what will be the work done value?
0.
Work done will be 0. Okay. So work done value will be 0. So theta is equal to 90, cos 90 0, work done will be 0. Then case 3. It is between 90 and less than 180. Between 90 and less than 180 degree. Cos theta will be negative. Cos 120 will be negative. In fact, I'll tell you how to calculate those quantity also after this, so that you will know in any numerical how to do it. Cos theta will be negative. So in that case, work done, which is nothing but magnitude of force, magnitude of displacement, and cos of angle between them. As you can see here, cos is negative. First two quantity is positive. So this is positive, this is positive, this is negative. If you multiply these three quantity, what will be the quantity?
Negative.
And we say a negative quantity will get. So work done will be negative. So these are three cases we have to remember for work done. Angle between force and displacement. Between 0 to 90, work done positive. Okay. 0 to 90, work done will be positive. If theta is 90, work done will be 0. Okay. And when it is between 90 to 180, work done will be negative, because cos will be negative. Okay. So these three cases we have to remember. Now, any doubt anyone in this? Any difficulty? Now, one thing here. Some of you may be knowing till 90 how to find the cos value. If it is more than 90, how to find? So there is one formula. Remember that formula, because maybe for NEET aspirant it will be difficult to find. Remember, cos 180 minus theta. Cos 180 minus theta is minus cos theta. Okay, if you'll see similar sine formula, sine 180 minus theta will be equal to plus sine theta. Right? 11th standard trigonometry, the explanation is there. For the timing, just remember the formula. For physics part, we don't need more than this for this work done, because it is maximum going up to 180 only. So if it is 120, how to calculate, I'll tell you. Minus tan theta. Okay. So suppose we are interested in cos of 120 degree. Right? How to calculate? So we'll write cos 1. What is 120? Can we write 180 minus 60? Can we say then it will be minus cos 60? Cos 60 is how much? Minus 1 by 2. So it will be minus 1 by 2. Means cos 60 is 1 by 2. So minus 1 by 2. Similarly, suppose someone is asking cos 150. Okay. So cos 180 degree minus 30 minus cos 30. Okay. Minus root 3 by 2. Okay. So if it theta is more than 90 and of course less than 180, negative values of cos will come, which will make this work done as negative. Okay. Now, anyone has any difficulty in this?
Yes, sir. At the down below that you just told, sir. Yes, sir. In this, sir, why we have take 60, sir? Why not 120?
Huh? What you will write? Cos 120 equal to cos 120. Then we'll again write cos 120. Again we'll write cos 120. How will solve it?
In the mid bracket, sir. After 120, cos in bracket 80 minus 60, sir. Why we have taken 60? Why not 120?
If cos 60 is asked, if cos 60 is asked, cos 60 we know directly, na? 0 to 90, you know the values. That's most known values between 0 to 90. This is, I'm telling, if it is more than 90, then some people find it difficult to find the angle. So we can apply this form.
Yes.
Okay.
Yes.
Cos 60 directly we know now 1 by 2. Why we'll apply for cos? Even if we'll apply, it will come same one. Suppose someone is saying, no, I want to apply cos 60 by this formula. Suppose the student is quite insistent about it. Is insisting, no, sir, I want using this formula only. No problem. Can we write like this?
Yes, sir.
180 minus 120. Can we write this as minus 1 cos 120? Cos 120, how much it is? Minus half. Minus minus will be how much? Plus half. Okay.
Yes, sir.
But why we'll do it? Because we should not apply for cos 60, because already 0 to 90, everyone is, that's the minimum value, first quadrant value. Everyone is generally knowing. This is the first quadrant, 0 to 90. This is the second quadrant, 90 to 180. This is the third quadrant, 180 to 270. This is the fourth quadrant. Okay. Here in first quadrant, all quantities will be positive. Sine, cos, tan, everything positive. Here sine will be positive. And 1 by sine will be positive. 1 by sine is cosecant theta. Cosecant theta will be positive. All silver T, tan theta will be positive. 1 by tan, cot will be positive. Remember, other quantities will be negative. Fourth quadrant, all silver T cups, cos will be positive. 1 by cos, secant theta will be positive. Like this quadrant wise, positive, negative will come, but don't ask more than this because it will come in the maths part. Okay, physics, what I told you, the formula sufficient. If you want go further, remember this formula, all silver tea cups. Okay, or one of the student told, which I don't agree, but I'm telling you, if you want to remember like that, all school torture student or children, C for children. Like that, he wanted to remember. You are free to remember in this way, but I feel that it is better to remember all silver teacups because that is what given. But whatever way you can remember it. All silver teacups. Okay, like this it will be. It should be better. Any doubt in this? Any difficulty? So this is work done by a constant force. There is not much difficulty about it. Now, next page we are going to discuss work done by variable force. Okay. Work done by variable force. So how we can make a quantity variable? Tell me, or constant. Have you seen that Flash? Flash, have you seen Flash? I think some serial or movie also comes, right? What happens in that? The person is moving very fast, very, very fast. What he feels about other objects? If you're
Moving.
moving, you will feel everything is at rest.
Yes, sir.
Even for a Flash or someone who is moving very fast, everything is at rest. So see, rest and motion is always relative, right? Similarly, when we say a quantity is constant or variable, generally it is variable with respect to what? With respect to time. T equal to 1 second, suppose force is 10 Newton. Force is 10 Newton at time is equal to 1 second. T equal to 2 second, it is becoming 11 Newton. So basically it is variable. But suppose I'll tell you I am interested in T is equal to 1.0000000000001 second. What is the force value? See, it is changing. It will change. It's a variable force, right? It's a variable force. But since the time is very small, we can still say force is 10 Newton, right? Are you able to understand the logic? If we are not giving the time for the force to change, or our observation time is very, very small, we can say that even a variable force will act like a constant force. So that's the point we should understand, that if time is very, very small, then we can assume variable force as constant force. That is what we have to understand it. If the time is very, very small, even the quantity is changing, but it's changing with respect to seconds. We are going in 10 to the power minus 15 second, in that range, minus 20 second, minus 50 second, 1 by 10 to the power minus 100 second. In that order we are going. So our time is such a small time that variable force will start acting like a constant force. So we can say that we can apply constant force work done, provided we are taking very small time. Or very small time means what will be very small? Very small displacement. Because if time itself is not given, even displacement will be small. So if you're taking very small displacement, meaning is we are talking about very small time. So what we'll do? We will calculate dW is equal to F dot ds. So if you'll apply this formula in calculus form, if you'll apply this formula in calculus form, dW is equal to F dot ds, then we can say that yes, force is assumed to be constant, even if it is a variable. Remember, it is always valid for a constant force. But other than constant force, it is now applicable for variable force, because ds is very small. Very, very small displacement or very, very small time. So force is a constant force. So we can write dW of a variable force is equal to F dot ds. Okay. Now we'll do the integration. So the work done by a variable force will be integration F dot ds. And it is a dot product. Other working will be same as constant force, like cos theta dependency. angle between cos and means F and ds. That's what I told you, that even variable force work done when we are trying to calculate, we have to apply constant force formula. But remember one thing, whenever force magnitude or direction is variable, again I'm saying, whenever force magnitude and direction is variable, right, and direction is variable, then we have to apply this formula one. Whenever force magnitude or direction or both are variable, variable means what, or changing, then this formula only has to be used. No formula will be used. Now, even if I'm telling you this thing, but I know I'm going to give you one sum after this, you people will do mistake in that. Even if I wrote in the ending that you should not do mistake, whenever force magnitude and direction or any one of them is variable, you have to use only this formula. Okay. Integration has to be used to solve this F dot ds. Okay. Now, any doubt anyone in this? Yeah, Janita, tell me.
The integration of work variables, work done variable force, where is it? I mean, I didn't understand the last step you have written.
No, you are asking when we'll do the integration?
No, like I understood the formulas, like integral of variable force is equal to integral of force into displacement. But after that, where is the integral of variable force? I didn't understand that part.
No, force, when we do the integration, force will be given in terms of displacement or force will be given in terms of time. Similarly, ds also will get in terms of dt. So then we can do the integration. So force as a function of time, ds as a function of dt has to be put in this to solve it. I'll give some example, then I think clarity will come. Okay. Suppose in a box, one example. Suppose there is a box. And we are saying there is a variable force of 10 times displacement, 10s. Means every time when s is 1 meter, force is 10 Newton. When s is 2 meter, force is 20 Newton. When s is 3 meter, force is 30 Newton. So force is variable force, even if direction is same. Right? Calculate work done by this force. For displacement of 10 meters. Right? Now it's a variable force. We'll apply the formula. Work done. Integration F 10s. Displacement is also in this direction. So into ds into cos 0 degree. Why cos 0 degree? Because both are in same direction. 0 to 10. Which will write 10 will be coming out of the integration. It's a constant. So integration 0 to 10 s ds. Now there is an integration formula. Those who are knowing, well and good. Those who are not knowing, maths class they can ask. S n ds will be equal to s power n plus 1 by n plus 1. It is applicant basic formula in calculus is like this: x n plus 1 by n plus 1. So power will increase. Here power is 1. So it will be 10, 1 plus 1, 2. Okay. So it will be s square by 2, 0 to 10. Or it will be 5 s square. Now we'll put the upper limit. This will cancel this, so it will be 5. Upper limit is 10. So 10 s square minus 0 square. So it will coming as how much? 100 into 5, 500 joules. Okay. So any doubt now? Now, Janita, you understood this? That how to apply the formula?
Yes, sir.
Yes, very good. So this way we have to see if any variable force is there. Calculus is the only way. As I told you in so many classes, calculus was developed by Newton. He was a physicist. Because in physics, we need the calculus. This type of scenario and many other formula in which we have constant formula, but we want for a variable. So you can see here that if time is very, very small, we can assume a variable force to be constant. Time is a small, displacement is a small. So we have to put ds and hence we have to apply the formula. Okay. So any doubt, anyone in this?
You show
So
the
this,
down part.
yeah.
Where you
What's the
worked-
doubt?
No, could you show the part where you worked out the question? Down. Thank you.
All of you just say it. Okay. Now we'll discuss some numericals. Okay. After this, we'll discuss some numerical. I'll give you one basic numerical. And then I'll see whether you understood the idea of this one. So this I'm marking again. Whenever force magnitude or direction or both are variable, okay, only this formula has to be used. Only this formula has to be used. We should not use constant force formula. We have to use calculus form formula. Okay. Any doubt in this? Now let's discuss one problem. Basic problem. But as I told you, be careful in answering because most of the people are answering it wrongly even after I discuss with this. Okay. Because you have to understand what I told you fully. Suppose there is one object. Okay. Here. Okay. Mass of this object is, let's take 5 kg. Moving in a circular motion of 2 meters. And there is always a tangential force in this direction. 10 Newton. Okay. Let's take this starting point is A. It goes to B. It goes to B. Then it goes to C. Then it goes to D. Okay. And the forces are like this: 10 Newton this side, 10 Newton this side, 10 Newton this side, 10 Newton this side. Okay. So this is there. So all these are 10 Newton force. Okay. Acting on this object. Calculate. The question is calculate work done. Calculate work done by 10 Newton force for one complete revolution or rotation. That is A to A. It is coming back to A. A to A. So try to calculate it. This is a very good question. Try to do this question. Calculate work done by 10 Newton force for one complete rotation. That is from A to A. It was asked in JEE exam. Try to do.
the 2 meter you have written is
Radius.
radius.
Radius. R is 2 meter. Radius is 2 meter. Calculate work done by 10 Newton force for one complete rotation, that is A to A. Try to calculate. It's easy question. How much will work done? How much?
0.
Yes, 0 will be one of the answer given by you. Let's see what others people are saying. Because if I'll say yes or no, everyone will know the answer, right? So let everyone try to get. Those who are trying at least should give the answer. See, 0 can be a correct answer. I'm not saying it is a correct answer now. Let some more people give the answer. Then I can say whether it is correct or not. Tell me what will be the answer. At least some more people can give the answer. What type of force we are dealing here? It's a constant force or variable force?
Variable force.
Which one? Variable or constant?
Variable.
Variable. Very good. So it's a variable force. Right? That is correct. This is a variable force. Now apply the variable force formula then. What is the work done? Work done by a variable force. Integration F dot ds, right? Integration F dot ds which will be equal to integration magnitude of force, magnitude of ds. What direction displacement is? Same direction as force. So cos 0 degree, which we can write as integration magnitude of force 10 into ds. ds is the small displacement. 10 will come out. Integration of ds. Integration of ds is nothing but adding all small displacement. How much that quantity will be? What will be the small displacement addition? Remember, not total displacement. We should not see total displacement. Object is from here to here, then here to here, here to here. Small displacement. Small displacement. Very small displacement. This also I'm showing you big. It's very small. It's a very small displacement. If you'll add this ds, this ds, this ds, this ds, everything has to be added because integration is nothing but the summation of the terms. So if you'll add all the ds from one point to another point, right? We are adding all the ds. We are adding this 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 ds. Everything ds. What will the sum of all this ds? How much this quantity will be? Can we say this overall quantity will be then 2 pi r perimeter, full perimeter or circumference 2 pi r. So what will be the answer here? The answer will be 20 pi into the radius 2. The answer will be 40 pi joules. Okay. So this will be the answer for this problem. It will not be 0. Because we should not see the overall displacement. What can be a wrong method for it? What will be the wrong method? We'll apply the variable constant force formula, F dot S. Magnitude of force, magnitude of overall displacement, and cos. Cos also will be a problem because force and displacement, okay, at each point this one. So you are taking overall displacement. Overall displacement is 0, so work done will be 0, which is the wrong method. Because overall displacement we should not take here. We have to take a small displacement magnitude. When we take a small displacement magnitude, it will never be 0 because magnitude is always positive. Displacement can be negative, positive. So overall, if you take displacement, it will come 0. But we cannot apply this formula first of all, because work done by variable force integration has to be used. The displacement has to be a small displacement. We cannot take overall displacement in work done by variable force. So that everyone should be able to understand it. Now this is clear. Any difficulty anyone can ask? Any doubt?
I have a doubt in that integration of ds. I mean, so now we're writing 2 pi r there. So the integration of 2 pi r would differ, right? Like
No,
2
see,
pi I understand.
Janita, see one thing. What is integration? Integration is nothing but the summation. Integration, if you'll see, is nothing but summation. It may be as a NEET aspirant you are not knowing, but maths we discuss the integration formula. We do the summation. Now, what is meaning of summation? So if the object is here, it has to come here. This is a small ds. Then it will go this ds. Then we'll go this ds. Then we'll go this ds. Now, if you'll add all these ds, what basically it will come? It will come the entire circumference. That's what I wrote directly. 2 pi r.
Yes, I understood that.
Yeah. Any other doubt? Related to that only you asked how the integration ds is coming 2 pi r, right?
No, sir. Actually, I wanted to know integration of 2 pi r.
Integration of 2 pi r. No, so for the integration, dx dy term should be there. See, it is something like when we create a differential term, when we create a small term means differential term, dx, dy, dz. To get rid of differential, we need the integration.
Yes, sir.
So to use the integration, if someone is writing directly integration x, it has no meaning.
Okay.
Integration dx should be there at least, because if d is there, a small element is there. When we say integration dx means x, dx, we are adding infinite number of dx, so it will come as x. And of course, indefinite integration constant c will also come in that case. So, but x will come the value. Directly integration of 2 pi r has no meaning basically. Okay. Integration of ds is having 2 pi r.
Yes,
Okay.
yes. Now I understand.
Okay. So any other doubt anyone is having?